When I was a child, I was fascinated by space exploration. From Neil Armstrong's first walk to the moon to the Columbia space missions, I was captivated by how we understood the origins of our universe. These missions are often supported by new technologies we develop every day, such as robots like the NASA Mars rover. These robots are often sent to other planets like Mars to investigate possible signs of life. Now, just as we use our cell phones to communicate with our friends and family for faraway distances, NASA scientists use antennas on the Mars rover to talk with the rover so that the rover can send images and video back to Earth. Now, the antennas on the Mars rover right now are not strong enough to send the data directly to Earth. What happens is that this NASA rover first calls this large satellite antenna, who then sends the data back to Earth. Now, this way of sending the information back to Earth is reliable, but the only problem is that this large satellite antenna is very expensive to maintain. That is why the goal of my research is to develop a small but powerful antenna that allows the Mars rover to directly communicate with Earth, saving NASA millions of dollars. Now, this antenna design is actually very complicated because antennas that can typically communicate for faraway distances are physically very large. Now, physics tells us that the larger the antenna, the more power it can handle. More power, more reliable calls. Unfortunately, for a Mars rover, large satellite antennas are very bulky and quite enormous. Adding to this complexity is the need for this antenna to be continuously pointed to that of Earth's antennas at any given moment in time. Such an antenna that has all of these traits will help solve a puzzling paradox that antenna engineers have been trying to solve for decades. Small, but powerful antennas. In my research, I was able to develop an antenna that has all of these traits. My antenna is actually made up of small antennas. When you group them together, meet the required power levels. This reduces the likelihood of drop calls and it enables faster download speeds. This antenna is also quite lightweight, 2.9 ounces and 10 centimeter wide and 10 centimeter long. Also, the novel shape of these individual elements helps do away with complex alignment issues with those of Earth's antennas, guaranteeing reliable calls from Mars. With such a revolutionary design, not only will NASA save millions of dollars, but NASA scientists will no longer have to ask the Mars rover, "Can you hear me now?" Good. Thank you.